Hey guys, how's it going? All right, so continuing on, this is a very kind of a long first topic in the permutations and combinations unit. It's called permutations. And the topic today is called permutations with restrictions and permutations with repeated elements. All right, so guys, just again, specifically, what's a permutation mean? Okay, so just before we move on to the notes over here, suppose I have three letters, A, B, C, and I arrange them in this letter over here. Okay, well, if I just go ahead and switch the order of them over here, these guys are different permutations. Okay, so I'm going to say in brackets, these are like distinct permutations over here as well. Okay, now if I had three letters, the number of different permutations I had would be 3 times 2 times 1, or 3 factorial different ways we're going to arrange them. Okay, so permutations, let's put in brackets over here, a synonym for this word is arrangements. Okay, so we're talking about arranging different things. Okay, so when we're talking about permutations, we're talking about different techniques of how we can count different arrangements of objects. So, for example, 13, with the letters A, B, C, D, E, and F, how many six-letter arrangements are possible? Okay, so the way we do this over here, I'll do this two different ways. We're making six choices over here. There'd be six choices, then 5, then 4, then 3, then 2, then 1. So if we multiply those guys together, we get 720. What we learned in our last video is that this calculation here can be simplified as 6 factorial written like this. Okay. Now, for example, for our 13b here, on the same thing, so we have 6 letters, but now we're only making a 4-letter arrangement. Okay, so we're still using the same letters, A, B, C, D, E, and F, but we're making a 4-letter arrangement now. So now it's going to be with 6 choices, then 5, then 4, then 3. Okay, so same idea over here, except we're starting at 6, counting down, but we're stopping at, after we hit 4 letters, we're going to stop. Okay, so when we hit this 3, we're going to stop. So 6 times 5 times 4 times 3, 6 times 5 is 30, times 4 is 120, times 3 is 360. For part 2, how many 2-letter arrangements? So again, using A, B, C, D, E, and F, so we have 6 letters to choose from. We have 6 options, and then we have 5 left over. 6 times 5 gives us 30. Okay. Now, what we saw in our last section, in our factorial notation lesson, well, what's another way that I can write this? Okay. Well, this over here is the same thing as 6 factorial divided by 2 factorial. Okay. Now, the reason why this is the same is like how would I expand and simplify this? 6 factorial is bigger than 2 factorial, so it's going to start at 6 and count down. I'm going to stop at 2 factorial because there's 2 factorial on the bottom, and those guys cancel out. And we're left with 6 times 5 times 4 times 3. Okay. Similarly, for this guy over here, how can I rewrite this guy? Well, this is the same thing as 6 factorial over 4 factorial. Now, the reason why this works is exactly the same what I did in example before, but 6 times 5 times 4 factorial over 4 factorial. The 4 factorials cancel out. 6 times 5 equals 30. Okay. So what example 14 is saying is that we're trying to generalize what we just talked about in example 13. Okay. So if we have n distinct objects, how many arrangements of r objects are possible where r is less than or equal to n? Okay. Well, here's the formula it's going to be. It's going to be NPR, and I'll explain what this means in a second, equals okay. Now, so first of all, let's show what this means over here. This reads as n pick r. That's how we read this, n pick r, which means for the number of arrangements of R objects out of a total of n objects. So, for example, in the previous example, where we had 6 objects and wanted to arrange 4 of them, that would have been 6 pick 4 over there. So how would that formula work? It would have been 6 factorial over 6 minus 4 factorial, which is 6 factorial over 6 minus 4 is 2 factorial, which is this, where the 2 factorials cancel out, and we get 6 times 5 times 4 times 3. Showing for the other one, 6 pick 2 would have been 6 factorial over 6 minus 2 factorial, which is 6 factorial over 4 factorial, Four factorials cancel out, and it gives us our answer of 30 that we had before. Okay, example 15. A hockey coach has 16 players on his team. He needs to arrange 5 players to participate in a shootout. How many different arrangements are possible? Okay, so this question over here is going to be 16 pick 5. Okay, now again, guys, so 16 pick 5. So we have 16 in total, but we're going to arrange 5 of them. So 16 pick 5. Okay, so just again, what this calculation is giving us is this calculation here. Just confirming that this formula would give us this. This would be 16 factorial over 16 minus 5 factorial, which is 16 factorial over 11 factorial, which is 16 times 15 times 14 times 13 times 12 times 11. Oops, sorry guys, there's no factorials there. That was my mistake. Let me do this again. Equals 16 times 15 times 14 times 13 times 12 times 11 factorial over 11 factorial. And that gives us just what we had over here as well. Okay, so you guys kind of fire this into your calculator. Now, there is a way we can do this on a calculator, guys. Sorry, I don't have my calculator on my computer open yet here, so just bear with me for a second here. All right, so guys, just while I'm waiting for this to fire up here, I'm just going to go ahead and do example 16 as well. So you have 6 New Year's greeting cards and want to send them to 4 of your friends. Guys, one sec over here. Keyword that's not in here, these are different, right? There's not the same greeting cards, there's 6 different greeting cards that you have. So this would be like, you have 6, you want to arrange 4 of them, that'd be 6 pick 4, okay? So same thing as like 6 factorial over 6 minus 4 factorial, which is 6 factorial over 2 factorial, 6 times 5 times 4 times 3 times 2 factorial over 2 factorial, and we're getting this calculation right over here. Okay, all right, see if my calculator is ready to go here. Okay, so a couple ways just so you're aware of how the TI-84 Plus or TI-83 Plus will do for this, guys. If you're using a Casio calculator, guys, these have these features as well. It's going to be slightly different syntax and how you get that in there. So if you guys have it, just come and let me know, guys, if you have one of those calculators, and I'll show you how that works as well. So what we want to do is press the math button. and go over to probability. Okay, now what you see over here, we talked about this guy earlier on. Here's our factorial button over here, and here is our NPR button. Okay, so if I want to go back and just take a look at like 16 pick 5, for example 15 that we did over here, on your calculator you can get this done. So we want to press 16, math, probability, NPR, there's 16, pick 5, which gives us 524,160, guys, which is really the same thing as 16 times 15 times 14 times 13 times 12. There's 1, 2, 3, 4, 5 numbers starting at 16 and gives us this number right over here. Okay, so 16 pick 5 is this answer here. If we had to go and try this for example 16, our question answer was going to be 6 pick 4. We want to go 6, math, probability, NPR, 6 pick 4 equals 360. Same thing as this calculation, gives us 360 as well. Okay, so this is how our calculator works for this guy over here. For this guy over here. All right. Example 17. Suppose you have 2 beds to put but 5 bedspreads. How many ways can you put the beds on the bedspreads? Okay, and so again over here, guys, word I should have included in here. This is 5 different bedspreads. Okay, so these are kind of different bedspreads over here. So what we have over here, so this is like you're making 2 choices. I would have 5 choices for the first bed, and then I had 4 left over. 5 times 4 equals 20, or the same thing as 5 pick 2. Okay, so just this would give us an answer of 20 as well. Okay, how many ways can we, if we do A, B, C, D, E, F, and G, if there are no restrictions? Okay, so we have 7 letters in this case, so that would be 7 factorial if there's no restrictions. And for part B, if I only arrange 3 of the letters, that would be 7 pick 3. Okay. I'm just going to go ahead and do this on my calculator here. So this would be 7 factorial. I would go 7 math, probability, and 5,040. And for the second one, 7 pick 3. I get 210. So this answer was 5,040. This answer is 210. Okay. Again, guys, just another way of doing this question is we're making 3 choices. My choice number 1 for the first letter, I have 7 options. For the second letter, I have 6 options. The last one, we have 5 options, and this is where the answer of 210 comes. How do we get 7 factorial? What did that mean? We have 7, then 6, and we just count down like this, and that's what this calculation here gives us. This 5,040 is the same thing as going 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, 18. I think we did a question similar to this in the previous one, but the B and E must be side by side. Okay, so the way I'm going to treat this is we have A, comma, B, E have to be side by side. C, D, F, and G. So really what we're doing here is we're treating B and E as if they were one letter. Okay, so if we do that, instead of arranging 7 letters, but B and E are 1 letter together, we only have 6 letters. So the way you can arrange 6 letters is 6 factorial. But what we need to do is multiply times 2 factorial. And the reason is because we're talking about arrangements, right? So that means if I flip the order of any of the letters, that means I'm getting a different arrangement. So for example, A, B, E, C, D, F, G would be one of these 6 factorial arrangements over here. But if I was to flip the E and the B, so in other words, put the E first and the B second, that would be another arrangement. So which is why we need to be able to multiply this one by 2 factorial. So 6 factorial is 720, 2 factorial is 2, and we get an answer of 1440. Okay. Example D is a little bit kind of a trickier question. The letters A, B, and E must be separated. Okay. So what we're going to do here is A, B, and E must be separated. I can put therefore C, D, F, G are not separated. Make sense? Okay, here's the way we're going to do this. What I'm going to do is I'm going to place my letters C, D, F, and G. Now, they're not necessarily in this order, so I'm going to put like the spaces above them over here, but these are where the letters do not have to be, so these guys do not have to be separated, okay? But these arrows I'm going to put here, these are the spots where A, B, and E could go. So I could put an A here, a B here, and an E here, and this is going to guarantee that A, B, and E are going to be separated. I could put an A here, a B here, an E here, and again, that would make sure they're going to be separated as well. Okay, so the way this is going to work, if I'm looking at C, D, F, and G, there are 4 factorial ways of arranging C, D, F, G. Okay, now the way I'm going to look at the A, B, and E, if I'm looking at these arrows over here, so I can call this one arrow 1, arrow 2, arrow 3, arrow 4, arrow 5. Well, how many spaces, so where could my A go? Well, there are 5 different spaces where my A could go, okay? Now, let's place the B. Well, I've already used up one of those 5 spaces, so that means there's only 4 spaces left where the B could go. I've used up now 2 of those 5 spaces, so now there are 3 spots where that E could go. Well, 5 times 4 times 3 is the same thing as 5 pick 3. So this is going to be our calculation for this question over here. And I'm going to go to my calculator and go 4 factorial times 5 pick 3. So 4 math factorial. Okay, so there's 4 factorial times 5 pick 3. And I get an answer of 1,440. Okay, you arrange all the letters, but the arrangement must begin and end with a vowel. Guys, for our purposes, vowels in this course are A, E, I, O, and U. A, E, I, O, U. Okay, guys, I know that sometimes Y is a vowel, like in the word gym. You know, Y would be a vowel. For our purposes, guys, these are going to be the only 5 vowels we use, and that means the other 21 letters are consonants over here. Okay, so in this case, what are our vowels? The only 2 vowels we have are A and E in these list of letters over here. Okay, so if we have 1, 2, 3, 4, 5, 6, 7 spaces over here, well, this one could be A or E. That means there are 2 spots available here. And now I'm just going to go right to the last letter. The question is saying it has to begin with a vowel and end with a vowel. That means there's only 1 vowel left. Because if I use my A, this could be an E. Or if I use my E first, that means this one has to be an A. Okay. So far, so good. So we start with a 2, we end with a 1. Now we've placed 2 out of our 7 letters. That means there's 5 letters left. So that means that we have 5 bill here, then 4, then 3, then 2, then 1. And we would multiply these together like this. So this really ends up being the same thing as 2 times 5 factorial, which is 240. Okay, so that's the answer to 18E. Okay, So Mr. McMahon is arranging some books on his daughter's bookshelf for a total of 13 books. 3 are nursery rhymes, 4 are fairy tales, and 6 are pop-up books. How many ways can you arrange the books if the nursery rhymes have to be together, the fairy tales have to be together, and the pop-up books have to be together? Okay, so here's what we're going to do for this. I'm going to say that we have, here are the 4 fairy tales. Sorry guys, I'm going slightly over here. It doesn't really matter. And then we have 3 nursery rhymes. Guys, it does not really matter at this point which order I did these in first. And then we have 6 pop-up books. So 1, 2, 3, 4, 5, 6. So we have 6 pop-up books. There. Okay. All right. So over here, this is going to be 4, 3, 2, 1. Like this. Okay. And then we have our 3 nursery rhymes. 3 times 2 times 1. And then we have 6 factorial for this guy over here. So really the calculation we're doing so far, and we're not done here, is going to be 4 factorial times 3 factorial times 6 factorial. Okay. Now, one thing we need to do at the end of this, put some brackets here. You don't really need the brackets here, but I'm going to multiply this times 3 factorial. And the reason is because there's nothing to say the fairy tales have to be first, and then the nursery rhymes, and then the pop-up books. Okay, I could have put the pop-up books first, and then the nursery rhymes second, and the fairy tales last, or any arrangement of these 3 letters over here. So how many ways do I arrange the 3 types of books? Well, there's 3 types of books, and so that means there's 3 factorial. Okay, so it should be 4 factorial times 3 factorial times 6 factorial, which is 4 factorial times 6 factorial times 3 factorial, 3 factorial. Big number here, 622,080. All right, so that's our answer for this guy over here. Okay, in how many ways can 4 girls and 5 boys be arranged such that the boys and girls alternate? Okay, so in this question over here, we have okay, so we have 9 people altogether, and it's going to go boy, girl, like this. Okay, so how many boys do we have? We have 5. How many girls do we have? 4. Then 4 left, then 3 left, then 3 left, then 2 left, then 2 left, then 1 left, and then 1 boy left over like that. So really what we have is this one series of numbers is just 5 factorial, and then this series of numbers here is 4 factorial, which is 120 times 24. Bear with me, guys. I'm just going to go do this on my phone over here. It's 2,880. All right, part B. There must be a boy at each end of the row. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Has to be a boy here and a boy here. That means there's 5 boys here. That means there's 4 left over. Now, these are the only 2 restrictions that we have. Okay, so there's boy at the front, boy at the end. Okay, so now there were a total of 9, but we've placed 2 of them. That means we have 7 factorial in the middle. Okay, so I'm going to go ahead and do that on my calculator as well. We have 5 times 7 factorial is 5,040 times 4 equals 100,000, 800. Sound good? The girls must be together. Okay, so for this case, here's how we do this question. Okay, all I'm doing over here is by circling the people. When we treat the girls must be together, we're going to treat them as if they're all together like this. So in other words, we're going to treat them as if they were one person. So we have one person here, which is all the girls together, and then 2, 3, 4, 5, 6. So that means we have 6 over here, 6 factorial. But we have to multiply times 4 factorial because the girls do not need to be in this order or in this arrangement over here, and permutations is talking about the number of distinct arrangements. So how many ways can you arrange 6 or 4 girls? It's 4 factorial. Okay, so 6 factorial is 720. 4 factorial is 24. Our answer for this question is 17,280. Okay, Jane, Andy, and Heather have to sit together. So similar over here. Okay, and then the other 6. So again, guys, it's exactly the same as the last question, guys, just trying to give you guys a bit more experience with this, okay? So in this case, those 3, Jane, Andy, and Heather, have to sit together. And then, Billy, Charlie, Danielle, Elizabeth, Frankie, and George, like that, they can be, it doesn't matter where they are. So if they have to be together, we're going to treat them as if they're one person over here, okay? So 1, 2, 3, 4, 5, 6, 7 is 7 factorial. And we're going to multiply that times 3 factorial because Jane, Andy, and Heather do not need to be in this order over here. We can just rearrange those 3. Okay. So it's doing this calculation. We get pardon me over here, guys. Okay, so we have 7 factorial times 3 factorial equals 30,240. Billy, Jessica, and Charlie have to be separated. Okay, so in this case, let me back up for a sec. We have 9 people. Sorry, guys. Yeah, sorry. There's 9 people in total. So what we're going to do here is we're going to take the 6 people that do not need to be separated and arrange them. And that's going to be 6 factorial like this. Okay. Billy, Jessica, and Charlie have to be separated. So we're going to do this. Okay. So we have all these arrows where Billy, Jessica, and Charlie could be. All right. So if I'm placing Billy, how many spaces do I have for Billy? Okay, so far the calculation will be 6 factorial for these guys over here. Okay. Now for Billy, there are 7 spaces where he could go. He could go into here or here or here or here or here or here or here. Okay, so there's 7 spots. Then Jessica, she has 6 arrows where she could go, and then Charlie would have 5. Now this calculation here is 7 pick 3. Okay, so this calculation is going to be 6 factorial times 7 pick 3. So 6 factorial is 720 times 7 pick 3 is 151,240. 100. All right. Okay. Consider the word unbiased. How many words can be formed with the letters of the word in which no two vowels are together? So this is, guys, very similar to the last question over here, but we're saying the vowels have to be separated. So again, our vowels are A, E, I, O, U. Okay, so we have U, I, A, E are vowels. And then we have N, B, S, D. N, B, S, D are four consonants. Okay, so we have 1, 2, 3, 4 consonants over here. So there's 4, 3, 2, 1, and then I have 5 arrows where my vowels could go over here. So this answer is going to be 4 factorial times 5 pick 4. Answer to that's going to be is 2,880. Okay. Example 22. List all the distinct permutations of the letters T. Okay. So in this question, we have two different types of tea. Tea the drink, then tea that you hit a golf ball off of. So the question is asking us to list them all. Okay, so here's what I'm going to do. So the first one, we have T, E, A. What I'm going to do next is I can still begin with T, but I'm going to flip these two letters and make it T, A, E. My next one, I'm going to start with E. Then flip the second two letters and I get eat. Then I'm going to start with A. Then flip the T and the E. Okay. Guys, at the very least, like that, this unit's going to make you a better Scrabble player. All right, so here are the 6 different permutations, which makes sense because if I have 3 letters, it would be 3 factorial, which is the same thing as 3 times 2 times 1, which is 6. Well, these are the 6 different ones over here. Now, what I'm going to do for this one over here is I'm going to kind of list them out again. I'm going to follow the exact same pattern that I followed over here. So my first one would be T, E, E. Flip the second 2 letters. Begin with the first E. Flip these ones. Begin with the second E. And then flip the other ones as well. Now, what hopefully we're saying over here, the question said, list all of the distinct permutations of the letters. Okay, well, the idea is like T-E-E and T-E-E, these are not distinct permutations. These are actually the same thing. So I'm not going to count them twice. E-T-E and E-T-E, I'm not going to count those ones twice. And then E-E-T, E-E-T, I'm not counting those ones twice over here too. So the only distinct permutations I have here are these 3. Okay, so these are your 3 distinct permutations. Okay, now here's how we did this one. Okay, well, if I have 3 letters, I'm going to say 3 factorial ways of arranging them. But if I have 2 letters which are the same, I'm going to divide by 2 factorial. And that's going to be 6 divided by 2, and that gives me 3, which is these 3 right over here. Okay. So, for example 23, given n objects where A are identical, B are identical, C are identical, determine the number of distinct permutations. Well, the answer to that question is this. Like that. Okay. So if I have n factorial over A factorial, B factorial, C factorial. Okay. So let's just, I'm just going to add an example over here. How many permutations using the letters this is my name, Pete. Okay, so for this question over here, the answer would be 4 factorial divided by 2 factorial. 24 divided by 2 is 12. Noon. This answer would be 4 factorial divided by 2 factorial. 2 factorial is 24 over 2 times 2, which is 24 over 4, which is 6. Okay. Guys, this is a classic question over here. Mississippi, ton of repeated letters in this one. So for this question, I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different letters. So it's 11 factorial. But I have 4 I's, 4 S's, and 2 P's. Okay, and so that's how this calculation works out over here. Okay, so guys, I'll let you do that in your calculator, figure out what this is. And what I'm going to suggest, guys, make sure that when you're dividing it on your calculator, that you actually go, so it goes 11 factorial divided by bracket 4 factorial, 4 factorial, 2 factorial, like this. You want to make sure you're dividing by your entire denominator like that. All right, guys, I hope this makes sense. I know this is a bit of definitely a very long first topic for this unit over here. But this is how permutations work, okay? Guys, just as always, guys, it's really important. You need to keep up with the practice in this unit, okay? If you don't, guys, you just need to have experience seeing all these questions so you know how to do them and be able to figure them out like this. All right? As always, guys, send me a message or see me in class if you have any questions.